Okay, thank you very much, sir, for giving me an opportunity to deliver my work there. So, actually, I'm not going to present some laboratory work. It's just a bioinformatics work because last year just I joined here, and I do not have much work to show here in front of you guys. So, actually, the main theme that I have found that the two drugs, that is curcumin along with the hydroxychloroquine. uh, I downloaded their structure from the PubChem database, and I have since this SARS-CoV-19 is already their structure is available, so I took the proteins as a structure, and then do the docking studies. So in SARS-CoV-19, we have targeted by using these two drugs, two receptor binding protein. One is main proteases, another one is receptor binding protein, that is S1 protein. So here in the figure you can see the hydroxychloroquine, and that is the drug we were using against the COVID-19, which have very strong binding affinity with the main proteases of COVID-19, and also the this curcumin you can see here. Here is the curcumin, which have a very strong binding affinity with the main proteases of COVID-19. So chloroquine as well as curcumin, it have a binding affinity with towards the main proteases of COVID-19. And the second, we have target the receptor binding protein, which is available on the COVID-19. So it also shows the binding affinity towards the hydroxychloroquine or curcumin. So here is the result that we obtain due to the binding. So we found that hydroxychloroquine and curcumin, which it binds with the binding energy of minus 24.58 joule per kilocalorie per mole, and curcumin has minus 20.47 kilocalorie per mole. And the S1 receptor binding protein for these two drugs have the minus 35.87 kilocalorie per mole and 38.84 kilocalorie per mole. This designates that these two compounds have a very strong binding affinity towards the main proteases of COVID-19 as well as the S1 receptor binding protein. So here is the proposed model that we are thinking to work on it. So it shows that since SARS-CoV-19, it binds with the ACE2 receptor of our lung cells. So, and after binding, it produces the RNA, and then translation, and then polyprotein is produced, and then structural protein produced, and it binds with the RNA molecule get integrated in the capsids of this virus, and then fusion with the endoplasmic reticulum. Then it goes to bind with the Golgi body, and these virion particles releases outside the cells to infect another cells through the exocytosis. So what curcumin and hydroxychloroquine does, it inhibit the receptor binding protein as well as it also infect the main proteases of this SARS-CoV-19. So that's all. That's all about my presentation, and I will be very happy if there is any query, and I will be able to answer. That's all about my presentation, and thank you very much for giving me an opportunity.